When you think about nuclear fission, you probably think about this, one of these, or maybe even this dude. Ironically, he wasn't even particularly significant in contributing towards its discovery, though his theories did help the process along the way. Instead, you should be thinking about one of the most brilliant and possibly least recognized scientists of the times. Throughout her life, she had to fight against racism and sexism, both in the scientific and political scene. Still, her discoveries have massively influenced the world we live in today, and since she has had an element named after her, in addition to some craters on both the moon and on Venus. This is the story of Lise Meitner. Lise Meitner was born on November 7th, 1878, to a highly intellectual family, which encouraged all their children to receive a good education and fought against the norm to have their daughters in school, using private tutors sometimes when necessary. Meitner became the first woman to study physics at the University of Vienna in 1897, and it was here she met a professor by the name of Ludwig Boltzmann. Now, if you are unfamiliar with the name, he was one of the fathers of modern atomic theory, identifying the presence, motion, and collective energy within a system. Today, the symbol K is known as Boltzmann's constant and is used heavily in modern thermodynamics. Boltzmann encouraged Meitner's studies and had no qualms about allowing women to study in the university, despite the norm in Austria at the time. Unfortunately, with his ailing health, Boltzmann eventually took his own life in 1906. As tragic as this was, it unwittingly spurred Meitner's career to the next level. It was at Boltzmann's funeral that she first met Max Planck, a physicist who pioneered quantum theory, discovering that energy existed in chunks, which he called quanta, as opposed to a continuous stream as previously believed. In 1906, Meitner received her PhD, and the next year traveled to Berlin in search of new opportunities. She studied at the University of Berlin under Max Planck, who for the first time was allowing women to attend his lectures. It was also in Berlin where she would meet Otto Hahn, an accomplished chemist, and they would become partners for many years to come. She would soon leave the university, and they would work together at the Kaiser Wilhelm Institute for Chemistry. Unfortunately, 20th century Germany wasn't the most practical time or place to conduct extensive scientific research. When World War I began, Meitner would become a nurse and an X-ray technician for the Austrian army, devoting her efforts into saving lives and putting her experiments on hold. Following the war, Meitner would actually be appointed the head of the physics section of the Kaiser Wilhelm Institute of Chemistry. In 1917, Lise and Otto would discover the element protactinium, a heavily radioactive element with virtually no practical uses, but still a very important discovery nonetheless. In 1926, Meitner would become the first female professor at the University of Berlin and would give her first lecture, the subject being radioactivity and cosmic physics, an incredibly complex subject. This was a huge step forward because Germany was considered one of the most oppressive countries towards women in education. In 1932, James Chadwick made one of the most important discoveries in the history of chemistry, the neutron. It turns out that the nucleus of an atom was made up of two separate subatomic particles, protons with a positive charge and neutrons with no charge whatsoever. This was important because a scientist by the name of Enrico Fermi theorized that by shooting neutrons into pre-existing atoms, it would theoretically be possible to create new elements. This principle would be incredibly important towards the discovery of nuclear fission, and it works something like this. If I take a Nerf gun and load it full of bionicle parts, and I shoot it at a bionicle, logically, I'm just going to get a bigger bionicle. The same is true with atoms. By adding more subatomic particles to an atom, they get new, bigger, larger atoms, in this sense, creating new elements. Around this time, another scientist, Ida Nodak, wondered if it would be possible to break apart a nucleus, creating two separate atoms in the process. Radioactive decay was well known within the scientific community at this point, so this theory had merit. But Nodak herself didn't really know how to forcibly cause an atom to split, and resulted in the idea being sidelined for many years to come. As Otto and Meitner's research continued, they would add two more people to their team, Fritz Strassmann and Otto Frisch, who was actually Meitner's nephew. Unfortunately for the scientific team, another world war was on its way. In one of their correspondences, Meitner wrote, "Last week we already had received instructions from the Kaiser Wilhelm Society to hoist the swastika flag beside the black, white, and red. This proved to be a bit of a problem for Meitner, as her family was of Jewish descent, and she began to worry. She saw her fellow Jewish scientists being forced to resign their positions and sometimes disappearing altogether. For the most part, she attempted to keep her head down and continue with her research, but eventually she was forced to step down from her position, and she later fled to Switzerland to continue her experiments at the Nobel Institute for Physics in Stockholm. This would be another major injustice, because her name was removed from all research that she had conducted with Otto, and he was given all the credit for their shared work. Meitner and Hahn remained in contact with one another and were able to continue their research independently, Hahn working with Strassmann and Meitner working with Frisch. In 1938, Hahn and Strassmann made a puzzling discovery. Uranium is a radioactive element, meaning that it is naturally unstable and decays over time. Radioactive elements emit either alpha particles, which are consisting of 2 protons and 2 neutrons, or beta particles, which are essentially electrons. In this process, the decay goes on to change the atom itself, and the mass is reduced, becoming a new element. This process continues until the element becomes stable. Uranium will eventually become thorium, which then becomes radium, radon, so on and so forth, until it becomes lead, though the entire process typically takes hundreds of thousands of years. What Hahn and Strassmann found to be so puzzling was that after bombarding uranium with neutrons, there were traces of barium to be found among the remnants of the decay. Now, this is extremely odd because barium is not a radioactive element and is not found on the uranium decay chain. They sent their findings to Meitner and Frisch, who also struggled to explain what happened. They double-checked their work and making sure there wasn't a mistake in their calculations, but everything checked out. It was a complete mystery until Meitner proposed thinking about the atom's nucleus more of a liquid as opposed to a solid. Working with this new model, many calculations and experiments ensued. They concluded that if they split the uranium nucleus, the 2 daughter nuclei would be driven apart with about 200 mega-electron volts of energy, and would have a combined mass of about 80% of what the original uranium nucleus was. This is where Einstein's formula comes into play, because he had discovered a correlation between mass and energy, E equals mc squared. After running the numbers, the amount of mass missing from the nuclei was equal to the amount of energy that the nuclei emitted when it was split. Once they had figured this out, Hahn went to publish their work, but found himself in a bit of a predicament. He was in the middle of Nazi Germany, and adding the name of a Jewish woman to the paper could have some serious repercussions on his name. So he and Strassmann left both Meitner and Frisch out of the publication, taking full credit for the discovery. While it may have seemed understandable at the moment, Hahn would later receive the Nobel Prize for Physics in 1944 on his own, despite Meitner's crucial contributions to the discovery. Now, some of this may have been due to some clerical errors, but nonetheless, it was another injustice against Dr. Meitner. As the war continued, the race to weaponize nuclear fission began. Werner Heisenberg was tasked by the Germans to find a practical application for the science. Fortunately for the rest of the world, his division was unsuccessful and was not able to produce any weapons or energy sources. Some historians actually believe that he intentionally sabotaged the efforts of his team, knowing full well what sort of destruction could be unleashed upon the Earth if he succeeded. At the same time, the Manhattan Project was founded in an attempt to create a nuclear bomb. In the process of fission, multiple neutrons were shot off from the original nucleus. If we recall, the fission process began with a single neutron striking a uranium nucleus, releasing energy in the process. Now, if more neutrons were shot off and subsequently hit other nuclei, it could create a chain reaction, releasing insane amounts of energy, proportionately only to the amount of uranium that one could procure. Meitner was invited by the US government to join the Manhattan Project, but she adamantly refused, horrified by the fact that her discovery could lead to the deaths of countless people. When the bombs were dropped on Hiroshima and Nagasaki, Otto Hahn very nearly committed suicide, feeling immense guilt for what he had helped to create. Hahn would later become a very outspoken activist against nuclear weapons until he died in July 1968. He worked on a document called the Manaus Declaration, which was released in 1955, speaking about the dangers of nuclear weapons. The concluding statement was, "It is a delusion if governments believe that they can avoid war for a long time through the fear of these weapons. Fear and tension have often endangered wars. Similarly, it seems to us a delusion to believe that small conflicts could in the future always be decided by traditional weapons. In extreme danger, no nation will deny itself the use of any weapon that scientific technology can produce. At the same time, the Russell-Einstein Manifesto was released with a very similar message, though Hahn never signed it out of fear for being associated with communism due to the many Russian scientists who signed the document. Shall we instead choose death because we cannot forget our quarrels? We appeal as human beings to human beings. Remember your humanity and forget the rest. If you can do so, the way lies open to a new paradise. If you cannot, there lies before you the risk of universal death. As mentioned previously, Hahn would receive the Nobel Prize for Physics, and Meitner, despite being nominated for the award alongside him, did not receive any recognition. Despite this, she would eventually get some recognition as she was named Woman of the Year by the Women's National Press Club in 1946, and she, Hahn, and Straussman would receive the Enrico Fermi Award in 1966. For the rest of her life, she traveled as a lecturer, continuing to teach physics and encouraging women to study science, and supporting those who had been discriminated against in that field. Meitner never returned to Germany and became a Swedish citizen, helping them build their first nuclear reactor. She eventually died in 1992, which is only 30 years ago if you think about it. 5 years after her death, a new element would be discovered and named after her, element 109, Meitnerium. Fittingly, an element significantly heavier than uranium, because that's what she set out to find in the first place, alongside Hahn. Despite everything she had gone through, the injustices she suffered, the oppression she fought against, Meitner persevered and made incredible contributions to the scientific community. What began as a simple discovery in a lab inadvertently changed the entire world to the construction of nuclear bombs, but also nuclear energy, creating potential for immense good and also immense destruction. Nevertheless, it cannot be denied that Lise Meitner is one of the greatest scientists of all times, and will forever be remembered as such.